This class is concerned with sampling design. Now, right from the outset, it's important to note there are two approaches here. One is probability sampling and the other is non-probability sampling. Probability sampling is random sampling. It's a scientific approach to selecting a sample, and because of the way it's done, the results of the sample are generally speaking quite reliable. The results of the sample match the characteristics of the population, plus or minus some degree of error, what we call a confidence interval. So probability sampling is the best. However, it's expensive and it's complicated. It's also the subject of a separate video, so we're not going to get into it here. Instead, this class is going to look at non-probability sampling. Now, non-probability sampling, this is not as scientific or as reliable as random sampling, but it has got some justifications. For example, it may meet the requirements of the sampling objectives. It depends on what the sample is trying to do. It depends on what's required from the sample. So it may actually match that. But certainly it's much cheaper to do than random sampling. Random sampling means finding the respondent that is selected randomly. And that may involve considerable cost. Depends on where the person lives or how to contact them, or it depends on a lot of issues. So this one is cheap. Non-probability sampling is a cheap approach. And it's particularly useful in very tight time slots when there is an imperative to get the results as fast as possible. However, I keep emphasizing the results are not so reliable. It may be misleading, it may be subject to bias, it may be the results are wrong. When conducting random sampling, the interviewer or the researcher must be very precise. And if they make a mistake, then it's costly and complicated to correct it. With non-probability sampling, this is much more forgiving. If there's an issue or a problem, just pass on and pick the next one. So it's much more attractive in that sense. And also, sometimes the total population may not be available. So non-probability sampling is used instead. It's a quick way and a cheap way of selecting a sample, because perhaps the whole population couldn't have been selected, couldn't have been used to select a sample. So random sampling means you have to know the whole population to select out of it randomly. If you don't know the whole population, then non-probability sampling may be an ideal solution. Now the types of designs, well, these really overlap one with the other. It's convenience sampling and purposive sampling and snowball sampling, but really we could sort of start to run these together, and let's not get too worried about the finer points of the distinctions in this class. So we'll start with purposive sampling. So it's when you want to access a particular subset of people. The method is, when taking a sample, reject people who do not fit the particular profile. You've got a purpose. It's purposive. So you've got a purpose. Check that the people fit an analysis of what has been required by the sample, and if they don't, they're rejected early. They may be rejected simply by having a question up front, or do you buy brand X soap powder? If the answer is no, then they're rejected immediately. Thank you very much and have a good day. If they say yes, then you move to asking some germane questions about the product or whatever it is you're checking. So with the purpose of sampling starts with the purpose in mind, and the sample is selected to include people of interest and to exclude those who are not of interest. So there's a filtering almost immediately with this exercise. It's popular with newspapers and magazines, but as I said, the results may be misleading. Simply because somebody's conducted a survey means they have found the truth. It depends on the questions, it depends on how the sample was selected, it depends on... The only true way of doing it is random sampling. So everything else is a compromise. And with this type of sampling, the results may be misleading. So we shouldn't accept everything we see. It's also true for marketing research, who are looking to check for support for their product. So typically you start on the street approaching some likely people, likely suspects, and then starting with questions that reject people, that do not suit. As I said, do you buy brand X soap powder? Answer no. Then in that case, thank you very much, have a good day. Move on to the next one. Do you buy brand X soap powder? Actually, yes, I do. Oh, in that case, do you mind answering a few questions? And so on. Purpose of sampling is non-probability, and as I said at the outset, therefore it's subject to bias and to error. And error can be significant. The results actually could be downright misleading. So care has got to be taken. And whenever we see a survey and the results of a survey, we should check if we are serious about taking those outcomes from the survey. We should check to see how the survey was conducted, to see how reliable the results are likely to be. Let's look at snowball sampling. When you don't have access to sufficient number with the characteristics you're seeking, this may be a solution. Simply find people to study. It's as crude as that. Simply find some to study. Ask them to refer you to other people, friends of theirs, who might answer the questions as well. And then find those people and ask them for referrals. And repeat this continuously. So it's like a snowball rolling down a hill. It gets bigger and bigger. Here you start with some people. You ask them for referrals. They refer their friends. You go to their friends and ask them the same questions, and then you ask them for referrals, and in this way it amplifies, it gets bigger. And however, a researcher studying attitudes for a given product may start with, say, 10 consumers. These 10 are asked to recommend more consumers. These referrals provide additional context, and in this way the sample size is expanded. Now, the snowball effect occurs as referrals multiply at each step. For example, if you get 2 referrals from each person, then starting from 2 people you get 4, 8, 16, 32, so on. And that's what's meant by snowball sampling. It's just a system of using referrals. It's often used by salespeople. They particularly like it because if they make a sale, then it means the person buying the product likes the product. Now, if they can get 2 referrals or X referrals of that person, of that consumer, then the chances are that consumer will talk to his or her friends, say, I bought one, I'm very happy with it. So part of the sales work has been done. So trying to get referrals of customers in sales is a very good idea. That's the way it's seen. And snowball sampling is used in that respect. As I said, keep putting it up here. How the sample is drawn and how it's used, the wording of the questions, the environment in which the survey is conducted, and the referral system itself all leads to bias, and hence the outcomes may not be that reliable. I keep saying the same thing, but it is so important. People tend to associate not only with people with the same study selection characteristics, but also with other characteristics. It's possible that as the referrals go on, different characteristics, people's characteristics vary. So my friends' friends are not necessarily my friends. So different characteristics as the referral system goes. If I refer to two, and you go through those two, they may refer to two more, but those two may have different characteristics to me, and I started the whole process off. So characteristics may vary as it goes on, and that's a good thing, presumably, because it widens the scope of the research base. So this increases the chance of correlations being found in the study that do not apply to the generalized wider population. That is the downside of what I've just said. It is possible with referrals that my friends' friends may still have some characteristics in common with me. I don't know these people perhaps, but they may have something in common. And to that extent, there's a correlation between us all. And the whole sample is somehow correlated. And that correlation may not correlate to the characteristics of the wider community. And therefore, there may be an issue. The need to get a person to give a referral also means that the researcher has to form a relationship with the person and be nice to them. So the interview, if it is an interview in the survey that's been conducted, is going to be biased simply because the interviewer has to treat the respondent in a way that will produce the referrals. They have to build up a relationship with them, a friendly relationship, a relationship of confidence and trust and so on, and try to get something from them, the referrals to their friends, because it is a big thing to ask. But the outcome of the research itself may be biased because there is that need to form this type of relationship of trust. So biases may creep in as a result of this. Of course, not every referral has to be used. It depends on the number of referrals and depends on the resources that are available in conducting the survey. But not all have to be used. The snowball method is useful, but the precise people selected for, let's say, for interview may be subject to some sort of additional selection process where people say we will not select those people, they're too far away, or we have enough already, or so there is an element of subjectivity even with the referral process. It's also known as chain sampling, chain referral sampling, or referral sampling. So there are various titles for this. There are some references that may be used. And that really concludes this class. In the class we've talked about non-probability sampling, sampling that is just simply done for convenience. It's the most popular type is the Snowball one that we've emphasized. Trying to get referrals and trying to grow the sample in that way. It is biased, and all sorts of issues arise out of the way the process works. The fact that people know each other and are referring each other onwards means that the characteristics of that group will influence the outcome, and the characteristics of that group may not be the same as the characteristics of the population itself. So care and attention has to be taken into account when dealing with this type of sampling. The best type of sampling, the scientific sampling, is random sampling, subject of a separate video, complicated, expensive, but reliable, generally speaking. That concludes the video, so thank you for watching.